What is probability? The Random House Dictionary, first edition, defines probability as a strong likelihood or a chance of something, or the relative possibility that an event will occur. Or finally, the ratio of the number of actual occurrences to the total number of possible occurrences. These are three rather different definitions of probability. They allude to chance. They seem to refer to an experiment in which outcomes are not predictable. And the last one refers to the frequency of something. In other words, it implies that an experiment is repeatable. What sort of things does the word probability conjure in your mind? In this course, we'll consider so-called random experiments. These are experiments that may have several different possible outcomes and are repeatable. So, for example, I can toss a coin 3 times. That's an example of a random experiment. The possible outcomes are things like 3 heads in a row, or 2 heads followed by a tails, and so on. In fact, there are 8 potential outcomes in this case. Or I could roll 2 dice and record what I got on one of the dice, say the yellow one, and what I obtained on the red die, and record pairs of numbers like 1, 2, 1, 3, and so on. Again, a random experiment with essentially unpredictable outcomes. I could measure hand spans from little finger to thumb. Essentially, the random experiment in this case consists of choosing a person at random, say from some population, like a class, and conducting this measurement. There are several possible definitions of probability, as we have seen, and the first is the classical definition. In this case, we let S be the set of all possible outcomes of the random experiment. For example, 6 if I throw a die. Then the probability that an event occurs is the total number of ways that that event can occur divided by the total number of outcomes in S. For example, if I throw a fair die, then the event of interest is that we obtain an even number. Then there are 3 possible ways in which that can occur, and 6 outcomes in total in the sample space S. And so, by this definition, the probability of rolling an even number is 3 over 6. The second definition was alluded to in the Random House as a frequency or fraction of times that the event occurs in a very long series of repetitions of the experiment. This is only usable, of course, if the experiment can conceivably be repeated. So, for example, if I'm interested in the probability of heads on a given coin, I tossed the coin 10,000 times, I obtained heads 4,992 times, and I will, by this definition, use, at least as an approximation to the probability of heads, 4,992 over 10,000. In fact, to get a more precise idea of the probability of heads, I should conduct this experiment even more times than was done in this case. A third possible definition of probability is purely subjective. You see this, for example, in weather forecasts, where the probability of rain is said to be 0.3. An expert, with evidence and data obtainable from various monitoring apparati, has guessed that the probability that it will rain tomorrow is 0.3. This is a best guess, and that's what we mean by a subjective definition of probability. The classical definition and the relative frequency definition are consistent with one another. That is, if, for example, I define the probability of an even number when I throw a die to be 1/2 under the classical definition, if I repeatedly carry out this experiment, the frequency will get closer and closer to 1/2. This, of course, assumes that I constructed a model consistent with the physical world the die lives in. What element of subjective probability makes it a little bit more difficult in a scientific discipline? In science, we like experiments that are repeatable. That way we can validate the claim. If, on the other hand, I claim the probability of rain tomorrow is 0.3, it may or may not rain. And it's very difficult to repeat that experiment on subsequent days under exactly the same conditions. Subjective probabilities are, when possible, to be avoided in science. What characteristics do we associate with a random experiment? Well, as we've seen, if it's a truly random experiment, there should be more than one possible outcome. That renders it unpredictable in some sense. It should also be repeatable. It should be possible to repeat the experiment under similar or identical conditions. When I toss a coin or throw a die, it's possible to repeat that, although the conditions may not be exactly repeatable. And it may or may not have equally likely outcomes. There are, of course, experiments in which some outcomes are more probable or more likely than others. Here, we'll be working with probability models. What is such a probability model? Well, it requires several ingredients. One ingredient is the sample space. The sample space is a list or a set of all the possible outcomes that a random experiment might assume. A probability model has associated with it events, sets of events. Events are simply subsets of the sample space, and events may potentially have assigned to them probabilities. And finally, we have to have some sort of device for assigning such probabilities. Probabilities are, by convention, numbers between 0 and 1. If you wish to select some other universe and associate probabilities between 0 and 2, or between -5 and 19, then that's okay too. However, that's not traditional in our mathematical universe, because we like to think probabilities are like relative frequencies, which are restricted to the interval between 0 and 1.
Here's a review question that you should think about on your own. What definition of probability applies to each of the following experiments? 1. The market price of this stock has increased in January for 8 of the last 10 years. So the probability that it will increase again this January is 0.8. What kind of definition of probability is that? What's indicated is a frequency, 8 out of 10. This is adopted as a probability of a reoccurrence of this event. Evidently, this is closest to the frequency definition of probability, where we define probability as the long-run frequency of an event. We can hardly say that 8 out of 10 years constitutes a long-run frequency. It's a relatively small sample, of course. And one could also argue that each of the last 10 years is not a simple replication of the same experiment. But nevertheless, this is closest to the frequency definition. 2. Experts suggest that the probability of at least a 0.25% increase in interest rates over the year is 0.9. What kind of definition is this? Whatever data these experts may have used about the past and the future of the economy, it's evidently a subjective view. And so this is a subjective definition of probability. 3. The probability that a newborn baby is a boy is 1/2. This is certainly not a relative frequency definition. In fact, the relative frequency of boys is somewhat higher than 50%. It could be your subjective probability assigned to a boy, although many people believe strongly that their child is more likely to be a boy or a girl. Rarely is their subjective probability assignment also 1/2, so it's probably the classical definition, where we've simply used a symmetry. There are 2 possible choices, boy or girl, and so we'll assign a probability of 1/2 to each of them. It's not a perfect model, but it's a reasonable model, reasonably accurate model for what actually happens.